Hi there. So I'm going to do my best I can to pull off a little urinalysis lab. These are some pretty important concepts that this covers, and we would be doing these things in the lab together if we were allowed, but I'm going to demonstrate them as best I can. This camera doesn't do the greatest job of focusing up close, so I'm going to try this the best I can. First thing you're going to want to do is go to your um, go to your Canvas site, and under labs, you're going to have the Renal Urinalysis Lab. And it has a lot of things on here. See this, if I can get on the screen there. The Renal Urinalysis Lab, it has all of the things that we would be doing if we were there. We're going to measure normal urine. We're going to see if it has blood in it. We're going to see if it has glucose in it. We're going to talk about what it will mean if your urine has stuff in it that it's not supposed to. The samples I have down here, I'm only going to do 3 samples instead of doing as many as we would do in the lab. So just put sample 1, 2, and 3. The diagnosis, if it's glucosuria or glycosuria, if it's hematuria, if it's high specific gravity, if it's low pH, or something like that, then put those things in there, and take a picture of this and send it to me, and this will count as you having done this part of the lab. The urinalysis factors that we're looking at include, you have this box. This is the thing I was waiting for from Amazon. I ordered from Amazon, and this is a set of glucose strips, and it has colors down it, and you can check 11 different your urine for 11 different components, including glucose. People use these most to see if they have diabetes. So if your glucose is in your urine, then yes, you have reached your transport max, and yes, you have diabetes. Other things on there, you have blood, you have proteins, and so forth. And this list that I have put on here for you, you have leukocytes. You're not supposed to have white blood cells in your urine. If you do, you have an infection, kidney or urinary tract infection. Nitrites, no. Urobilirubin and bilirubin. Remember bilirubin, liver, liver, liver. Bilirubin is a coloring agent that is in red blood cells, and when they break down, your liver filters out the dead red blood cells and takes that bilirubin and puts it in your bile. It's why your bile is yellowish green. And if you have too much bilirubin in your blood, it means your liver isn't working right. It isn't filtering it out. It's an indication of liver damage. And with with liver damage, you get jaundice, which your whole body turns yellow. The whites of your eyes turn yellow because bilirubin is building up in your blood. Your pH should be slightly acidic, somewhere between maybe 6 and 7, 6.0, 7.0. Shouldn't have proteins. You should be reabsorbing all of your proteins. Specific gravity. Remember, that's how heavy your piss is compared to pure water. So urine compared to pure water, if it's a little bit heavier, then you're probably dehydrated. It could have other constituents in it that are making it heavier, some extra proteins or things. So sometimes high protein might mean high specific gravity, but usually it relates to your hydration status. Overhydrated, it's too low. Dehydrated, specific gravity is too high. Your urine is too concentrated. And so specific gravity, it can be really low or really high without meaning kidney disease. But normal, you could say about 0.01 to 0.025. That you could say that's relatively normal. 0.01 to 0.025. It can be lower and higher and not mean kidney disease, but it's not exactly normal. You're probably dehydrated or overhydrated. Ketones, people check that a lot if they're afraid they have diabetes. You make ketones when you're not utilizing your glucose properly, and there's bilirubin down there at the bottom as well. And you shouldn't have any glucose in it. You know, glucose means you have glycosuria. Glycosuria. So we're going to look at a few samples and see if they have any of these things. Here's some normal lab values at the end of that sheet too. It says about what they should be. You know, here it says pH 4.5 to 8. Again, 4.5 is really low and 8 is really high. That's not exactly normal, but it can be that low or high based on diet and things like that. It don't necessarily mean you have kidney disease, but somewhere between 6 and 7 is more common. Specific gravity, really low to really high. Really, you know, 0.01 to 0.02 is probably, you know, a good range for normal specific gravity. Glucose should be basically none. This is a tiny amount. No ketones, no proteins, no blood, and so forth. So those are your normal values. Okay, so let's click back on here. And I'm going to put this back. Now see if I can actually okay, that's sort of stable. I've got wind coming in. It might blow it over. Okay, so the first sample I'm going to do, I'm going to take one of these samples, and you can look on here if I can get it to focus. There we go. See, leukocytes, nitrites, urobilirubin protein, your pH, blood specific gravity. There's your ketones. Come on, let's focus again. Come on, guys. Focus again. It's not focusing for me. There we go. Ketones, bilirubin, and glucose at the bottom. And it's based on colors. So each of the strips has colors going down the side of it. I'll take one of these strips out. And you dip it in your urine sample. And I have some factory-made urine samples here that I'm using. Here's the sample stick, and it has those same values on it. And then you measure it up once it's wet. You measure it up next to the values on here, and you see if they are the right color. If they're the right color, if they're that color or lighter, it means that you don't have too much of whatever that is. If it's darker, you move along here until you find the correct color, or the color that matches it the best. And then you say, okay, well, it's that high. My glucose is that high, or my blood is that much. And I'm going to try to make this happen for you. The first one I'm going to do is, this is a normal urine sample. So I'm going to dip it in there. And I tap it on a piece of paper to get the excess off so it doesn't run too much. I'm going to close this back up before I knock it over and spill it. Wait a few seconds for it to react. And then I hold it up next to my jar. Okay, here's my jar. So I can look at these colors, if I can get it to focus. See if I can get it to focus. Try it again. See if I can get it to focus. Okay, that's not too bad. So here we have all of the colors, and they're basically the same color as you're seeing next to them. I mean, they're not exactly identical, but they're very close to the same color or lighter. You can see this one's a little lighter, excuse my fingernails, I've been gardening all day. Okay, and here's glucose at the bottom. It's about the same color. So this is a normal urine sample, and it's coming out about the same colors as the jar. Earlier it was focusing so nicely. And now it just is refusing to do it. Okay. So now I'm going to do my next sample. Turn it this way a little bit. Maybe the lighting, different lighting will help. Okay, so here's sample number 2. I'm going to do once again, I have my sample. And look at the color while we're doing this. You know, this is clear. It's not cloudy. It's not red. It's not frosty. It's not cloudy. It's not, you know, it's just clear and pale yellow. That's the color that urine is supposed to be. I'm going to dip it in there all the way in. And I'm going to take it out and tap it. Okay, so this sample, there it focused a little bit. Now it unfocused. Okay, that'll have to do. Okay, so we're looking at, if I can get it lined up here, all of these colors, okay, all of these colors, once again, are matching pretty close to the color of the one next to them, or slightly lighter, so that's okay. Look at specific gravity here. Specific gravity. Let's go over here, because it's not that color. It's right about this color. Maybe this color. 1.01. Is that normal? 1.01 specific gravity is about the color that this one. This glare is terrible. See if this works any better. Okay, not too bad. Okay, again, we're on this color right here, and this is about 1.01, and that would be normal. So the specific gravity is normal. Looking down at these others, they're either the color we're looking at or the right color, until we get to the very bottom. We have glucose. Aha, you can see it. Glucose. It actually focused for me. Glucose. Okay, you see that's not the color that it's supposed to be. It's supposed to be that light blue. Hello? Here. So let's move it over here to wherever it is closest. Okay. Well, now we have, it's very close to that color. Okay. Sorry about that. It's just, you know, it's between those two colors. Well, the thing is, you're not supposed to have any glucose. So the fact that you are not over here, in fact, that you're over here, you don't have a whole lot of glucose in this one. Yeah, there it is. You can see that color over here. You can see that color now. It's over about between here and here. So this is glycosuria. All right. This is really a lot easier to do it yourself than it is to watch me try to do it backwards, upside down, and backwards on a camera. But that's how it works. You just move it across until you find the right color. It's not that dark. It's about that dark. And then you read off the number. Okay. That was difficult. So let's try our third and final sample. I am happy to report we're going to take a sample and we're going to put a little sticker thing in here. Okay, and we're going to tap it over here on some paper to get the excess off so it doesn't run too bad. And we give it a few seconds to react. And now once again, we have our colors here, the colors that we're trying to compare to. And it's refusing to focus again. But we're going to look down here, and I'm going to put this next to it. And the colors are all matching up from top down to bottom until you get to this one. Look, this one is supposed to be this kind of light pinkish orange, and look how dark green it is. That one is the blood one. And if I move it across here, I'm going to find that it's about here. It's in that range. This is it right here. It's supposed to be this color. Supposed to be this color. Instead, it's all the way over here, this dark green color. That's blood, and it tells you the value, but the fact is, you don't need to memorize the value. You just need to know that there's not any blood in normal urine. It shouldn't have blood in it. Specific gravity is fine. Glucose, you can see the very bottom one, the color is fine. It doesn't have glucose. It doesn't have protein. It doesn't have, the pH is still about 1.010. That's this one right here. So that's about the right color. So 1.010 is perfect for that. So specific gravity. The pH is about, look here, 6.5. pH is 6.5. Is that right? Yeah, about 6 or 7. 6.5. That's perfect. The pH is perfect on this. Okay. The only thing this has is blood. Now remember, on your sheet that you have also, you'll find a couple of other things in there. For instance, if you have blood in your urine, there are two most likely possibilities. One is that you have a bad urinary tract infection and you're bleeding from the bladder or something like that. The other is that you had a blow to your kidney. A friend of mine, when I was in high school, was playing on the football team, and he was about to get tackled and was kind of hopping around trying to get away, and somebody smashed into his kidney with their helmet. And he had blood in his urine for 3 or 4 days, and they wouldn't let him play after that, which is a good thing for any number of reasons. But so you're not supposed to have blood in your urine, but it's a good indication. If you fall and land on a rock on your back or something, your kidneys are fairly susceptible to damage, and you can tell if you have kidney damage by, if there's blood in your urine. So if you have, we know what's a high specific gravity is if you're dehydrated. Blood in your urine, you probably got whacked on your kidney, or you have a bad urinary tract infection. Bilirubin, you have liver damage. Glycosuria, you have diabetes. Proteinuria usually means that you have kidney disease. The proteins, you're not reabsorbing them back into your blood like you should, and you start peeing some of them out. That's an indication of kidney disease. So knowing what these elevated numbers are, and those are, I put them on that sheet that you have in front of you now, hopefully. So learn some of those. These are the kind of things that are likely to be on the practical exam. Just general indicators like that. And there's one final thing, and that's specific gravity. These strips do specific gravity okay, but they're not the gold standard for specific gravity. The gold standard is to actually weigh the urine. This basically weighs exactly as much as water. I mean, it's glass, but it's got air in it. They've made it so that it weighs exactly as much as water. You pour the urine in there. If the urine is heavier, the thing will float up higher. If the urine is too light, if your specific gravity is too low, the water will be heavier than the urine and it'll sink down in too far. And if I can get this to focus and show for you, yeah, see those numbers on there? Oops. Okay. At the top, you have 1.000. That's water. Below that, you have 20. That means 1.020. Next one is 40. That's 1.040. Okay? 1.040, of course, would be too heavy. Why can't I get this to show up? 1.040 would be too heavy. Now I can't get it to focus again. There it is, 20, 40, 1.000. So it should be that first line beneath 1.000 would be 1.010. So theoretically, it should float right up to about the 1.010 line or 1.020 line. Somewhere between those two lines is how high it should float out of the water. And so you're not going to be able to see this very well. I'm sorry, but now that I've explained it, maybe you'll see what's going on. I'm going to pour this factory-made normal urine sample in there until it floats. And see how high it floats. Okay? It's floating, the top of the urine sample is floating at a number. And on this urine sample, it's floating at right about, it's about halfway between 1.010 and 1.020. I doubt if you can see that. You really can't. But you can imagine, I mean, the one right below there that you're seeing is that 20. So it's the 20 is a little bit below, the 1.010 is a little above, but all you do is read your scale at the level where it's floating, and that tells you what your specific gravity of this urine sample is. And since this is halfway between 1.010 and 1.020, it's about 1.015, so it's just about perfect. That's about where you want your specific gravity to be. So this person would not be either overhydrated or underhydrated. So knowing how the urinalysis strips work, they're real easy. It's like measuring your chlorine levels in your swimming pool. All you do is hold the thing up there and just turn it until the colors match up. And if any of them don't match up with that first line, you go to see where they do match up, and then you know how far off you are. And it will, and knowing some of the values, know about what normal specific gravity should be, know about what normal pH should be, 6 to 7. Normal specific gravity, maybe 1.010 to 1.020 is really normal. Much outside that range in either direction is either too high or too low. Know that you shouldn't have glucose. You shouldn't have protein. You shouldn't have white blood cells, leukocytes. You shouldn't have bilirubin showing up in there and what those things mean. Those are the kind of things that will likely show up on your practical exam in those like 5 or 6 questions I put at the end, in addition to just all the parts of the kidney, urinary, and the reproductive systems. Please email me if you have any questions, or if you weren't able to see what I was doing. I don't know that I could do it any better, but I might be able to explain it to you. Thank you. Good luck.